Okay. Hi. Good morning. Okay, so what's in there? T. It's like the sixth one at so estimating the area under the curve of one arch of sine. Anyone got a, Kate, what were you guys coming up with?
1.8 or 9 or something like that.
1.8 or 9. 2. 2.
You're so confident.
So what's Aiden? I can't believe Aiden and Caden are sitting next to each other. Caden, you used to be next to Caleb. Like, come on, people. Just defining names. It's killing me. So what was the reasoning with your 1.8, 1.9? How'd you?
Just grab it, just look at it.
It's like,
So like this square is like almost 1, and these guys are like each half a square, so kind of close to 2, but maybe a little less smudgy. Okay, so those of you in physics, area under the curve is the integration. And just to show you what this actually is doing. This is integration, finding the area under the curve. And if chapter 3 did not go well, you need to revisit chapter 3. Chapter 3 was doing derivatives. Integration is undo derivatives. It is hard to learn subtraction if you don't know add. If you find it going forward was hard, going backwards is really hard. So, for example, this one, how to integrate it is you just know whose derivative is positive sine, negative cosine. And we haven't done integration yet, I'm not meant to be teaching you this now, but just to show you this one example, this curly Q thing means do the integration, undo derivative. Once we've undone derivative, that curly Q moves to the other side and it becomes straight, which means evaluate it from 0 to pi. And we've done this kind of thing before, dy dx, straight bar when x equals 2, that means plug in 2 for x, blah, blah, blah. This has 2 numbers on it. The way we evaluate this, which is fundamental theorem of calculus, number rule 1 or 2, different books call it different things, but that's a ways from now. So we plug the top one in, negative cosine pi minus, plug the bottom one in, cosine pi, negative 1, so negative 1, negative cosine of 0. Oh, so it was exactly 2. Yeah, Matt just did that. It's 2. Yeah, a number of people said, all right, so today we're going to be estimating these areas under the curve, and we're going to do that with lots of rectangles. Rectangle approximation method. So we're going to take those curvy things, and we're going to draw rectangles in them and find the areas of rectangles. Asher, what's the area formula for a rectangle? Length times width, base times height. Depends on if you're like thinking of it sideways or straight and down, doesn't matter. Okay, so the width will be easy for us to find. And then there are different kinds of rectangle methods. I have to tell you where you're going to find the height. Do you find the height using the left side, the right side, the middle, something else? And we're going to do those today. Okay. I never do this well. This is my best effort of Well, derivative was, how is this thing changing with respect to that thing? It makes kind of sense that it's the slope. Y is undoing slope equal to area. This is my best shot. So, I am walking at 3 feet per second, and I walk for 4 seconds. How far did I walk in those 4 seconds? 12 feet. So 3 feet per second for 4 seconds. Seconds cancel out, I went 12 feet. If you look at the equation of the velocity as a horizontal flat line, 3 feet, 3 feet, 3 feet per second, times number of seconds, it's just a big old rectangle. The area is the distance that I moved. What if my velocity was, for every second, I got 2 times faster. The distance that I traveled in whatever 2 seconds would be the area of this triangle. Just is. So I don't have a good reason why integration is find the area of the curve. It works with this velocity thing, and if we took slices and just did lots of little rectangles, we could add them all together and get effectively this. Yeah, okay. Quinn's looking at me like, yeah, okay. All right. So we're gonna practice some of these. Homework tonight is on Delta Math, not out of the textbook. So this is saying, if we cut up y equals x squared into a bunch of little slices, I could say, find the area by taking the right end of the rectangle and calculating. Or I could say, find the area by taking the left end of the rectangle. I can tell you any number of things. So let's try a problem. Like, I'm gonna assign you guys a group, so don't start yet. But I want us to look at this equation. The way the questions are worded for these, 6 subintervals of equal length from 0 to 3. How big is each slice?
1/2.
Thank you, Ryan. 1/2. 3 to 0. That's the change in x, by the way. The width of each of these little rectangles is 1/2. Every single one, 1/2. You agree? Because the problem says 6 subintervals from 0 to 3, cut into pieces. Jacob, good? Yeah?
Yeah.
Hi. How you doing? Hi. All right. So. This is just my notation, but we need to find the area of how many rectangles? 6. So there's 6 different ones to calculate for this, 6 different ones for here, 6 different ones for there. Okay. This rectangle, this is rectangular approximation method. The L stands for choose the left end of that rectangle to find the height. Here, x was 0. I'm going to plug 0 into my equation, y equals x squared. 0 squared times the width. So using LRAM, that first rectangle had 0 area. For MRAM, I need to pick the midpoint between, what is it going to be?
A quarter.
A quarter? He said it with a question mark. Do you guys agree?
Yeah.
So all the x distances, 0, 1/2, 1, 3/2, 2, 5/2, 3. Choosing the midpoint, middle, between 0 and 1/2 is a quarter. Taking that x value, a quarter squared. In MRAM, using the midpoint, my first rectangle is 1/32. This one, use the right endpoint to find height. What is the x value here? 1/2, so 1/2 squared times 1/2 is 1/8. Okay, good times. So, these are tedious and I don't wanna make all of you do all of the things. You guys do the other 5 rectangles for LRAM, add all 6 rectangles together and get a number. Asher and Jacob, you guys are also LRAM. You guys, I apologize. It's Jan's fault. You are MRAM. And you are also MRAMs. So you guys gotta find the other 5 rectangles, add them all together. And you guys are RRAM and Will, RRAM, you're with them. Yes?
So I understand how we get the x value. How do we? Oh, the y value is like. Oh. Okay, that makes a lot of sense. That makes a lot of sense. Okay. 1, 2, 3. Yeah. You know what you're doing? Oh, you guys got an answer? Oh, no, we don't. Did not get
Wait, that doesn't make sense. Oh, no, it does.
LRAM, did you guys compare with each other? Do you
No, I
guys
think
have a
you
number?
just add it up and then.
You got 5?
So it does.
Wait, I have to multiply by 1/2 again.
You gotta add all the 6 rectangles
Yeah,
together.
so like every value in and then multiply it by 1/2.
Okay.
She just multiplied all of the values before.
Oh, I understand.
How would you do it?
And a different.
Which is about what?
Yeah, 91.
91/8 for this one, which is 7.3756. Maddie, did you guys get a number?
I got 55/8.
Which is
2 parts.
okay.
Remember we did limit
Yeah, I got
definition.
I got 55, yeah.
We didn't do limit definition for 2 months. We did it for like 3 days. Thank you. It felt painful because y'all hated it, but
That's so fun.
okay.
Why did I add them like that? Why didn't I just take out the calculator?
I also added them like that.
All right, to look at this, yay for technology, and for once I'm not being sarcastic. Okay, so LRAM people. there are 6 rectangles. You only see 5 because the first one is just a flat line with 0 area. So I heard 6.875. Yes, that's correct. Okay. Those of you who did MRAM, 8.9375. Yes. And those of you with RRAM, 11.375. So the numbers that people told me sounded right. So looking at this, like, and if those of you that did LRAM got the 11, it's because you did the sympathy rule. You were like, oh, well, that first rectangle, it didn't even count. It was 0, and you do an extra one. Don't do that. Don't do that. Don't do that. The first one was 0. You calculated it. You got a free ride on that one, but the 0 is the area of that first rectangle. Looking at this, is our estimate going to be over or under? This one is going to be over. LRAM is going to be under. What attribute of the graph makes it an over and under? Is it the concavity or is it the first derivative? Which one? What do you think?
Concavity.
Okay, so concavity. So that means if
Oh, it's both actually.
oh, that's speed. That's knowing if it's speeding up or slowing down. That you need both. Okay, so I just changed it for it's still LRAM, but is LRAM going to be an under approximation now over everything? No, so it's not concavity. What makes both? It's not concavity. First derivative then. So okay, if we're doing LRAM and looking at the first derivative and it's increasing, you're taking and then find the height at the lower part of things, and we're using that to approximate. Versus if it's decreasing and we do LRAM, we're taking the higher thing and we're overinflating our value, Donald Trump. No, really, I had this much at some point in time. It might have tanked overnight, and but no, really, this is the value. And RRAM. RRAM is an over approximation if it's increasing and you take that right side. Do I want you to memorize this? No. Do I want you to be able to reason through it and be like, okay, my function was increasing, draw RRAM rectangle. So using the right side and going over to get the height. Okay, that little extra bit of the triangle is going to hang over. It's going to be an over approximation. And it's over because it's increasing height. Bye. Okay, so I need to show you something else on there. Someone in first period was very concerned about accuracy and like, well, you know, what do we really need to know a more accurate answer? I'm like, well, we have ways. I could make you guys calculate 75 rectangles, and that's a lot closer and more accurate. It looks looking like, yeah, all over it. Let's go. No? Yeah.
What we're doing is, like, if we had, like, how do we know which one to choose?
Okay. How do you know which one to choose? They will tell you.
Okay.
So when you get these kinds of problems and it asks you something, they will say, use right rectangular approximation. Use left rectangular approximation. They will tell you. And Grady was like, what about the units? Like, when does that happen? When I give them to you. And we will do an example with units today. And the units will be like wacky crazy and we will adjust. Matt?
I was gonna ask, can you put that number all the way to the top? Then,
Here you go.
so
It looks almost filled in. It's a little bit over here, a little bit under there, so it's like average, it comes out okay. What?
I'm just figuring that out.
Okay. So, that's what this thing is saying. Well, would it be more accurate if we said there's 1,000 rectangles? Yeah. Are we gonna do that? No. We're actually gonna do an infinite number, but that's okay. And it won't take you forever. But in the meantime, what we're doing right now, I wanna see if you guys can, with a calculator, brute force through this. I want you to calculate using R rand, 6 subintervals from 0 to 3. What's the change in x? 1/2? 0, 1/2, 1, 3/2, 2, 5/2.
Is that x squared or x?
So find the area under the curve, approximated with that using R rand. So there's a small shortcut. Anybody, let's look back. I wrote this out as finding the area of the rectangles. They all had a width of 1/2, so I factored it out. So then all I had to do was f of 0 plus f of 1/2, and then multiply them all by 1/2 in the end. So this one, there's the smallest of shortcuts. Is the width for all the rectangles the same? And then RM, what is the first x value I'm going to put in to find the height? 0 or 1/2 or 1/4? 1/2, because I asked you to use the right side for the first one. Those of you who are good with the calculator, you will have an answer before I'm done writing. So find the numbers accurate to 3 decimal places. 3, I showed this. Yes.
I will actually use it. I can do it. Oh, you can just plug it into the. Oh, you can.
I did like, okay, I have a
Wait, no, I've lost it. What are we supposed to do?
I'm doing it in a really long, complex way. You're just trying to find.
Alright, so I've done it
There's
completely.
a
So
number.
you basically do exactly what she wrote out there. There's a,
Anyone get a
yeah,
number
there's a
yet?
fancy way to plug that in.
I started plugging it in and started messing with it.
No.
You said what?
Okay, let's see what it is.
Like 1.955.
1.955,
56.
That's all.
56.
I got 5.92.
So I was really off.
What did I do?
You got 11. Okay, maybe
Asher? Asher, what'd you get?
5.9.
What was your number?
Oh my god, I see what I did wrong. Oh wait, I see what I did wrong. Oh, I did.
5
You just plug it into the number.
Oh, and I can't even change it like that.
So, all right, guys,
I'm not doing all
okay, so first of all, those of you that got these answers over here, check to make sure you're not in degrees. for one thing? Yes, no? I don't know. Okay, so these are all looking really close. 5.926 is what I was expecting. Those of you that got these really, really close but a little bit off, if you took your intermediate answers and rounded them to 3 decimals, which I say in the end round to 3 decimals, if you did 3 decimals in between, by the end after adding 6 of them, there's enough error that built up that you could be off by that little bit, which is why AP asks for 3 decimals. Sawyer?
So how do you do any of this on the calculator?
Okay, I don't round anything. And I actually do what
Not
Isabella
just rounding, I'm entirely.
entirely confused. Okay. Got you.
Yeah, it seems very time consuming.
It is, and we don't do a lot of it. So the
I mean, I wouldn't put it past it.
I mean, it's like time consuming, but it's also like not, but like, let me not juice myself.
Okay.
It's like smarter, but like, it's not that hard, so it's-
all right, guys. So AP exam will definitely ask you one of these, and this is the first day of it, so there's not a lot of context yet. But scientific wise, they would have tables of data. They don't actually have an equation, but they have tables of data. At time 1, we noticed this much problem. At time 5, we found this much problem. Time 7, like at different time data points, they've got information. And then using the data in that table, let's just find quote area under the curve one way or another, and those who want to underestimate the problem, they'll choose the lower one. Like, does LRAM help us make our point, or does RRAM help us make our point? So, Sawyer, how to do this quicker? So, Annalise, Isabella, you guys found a better way to do this?
Okay, that's what I did.
Like, what was your suggestion, Isabella? You said
I
do.
plugged it into Y1 and then I got out of it and then I just went to bars Y, next one, yes. And then I pressed the long values, added them, and multiplied by 1/2.
So, did you do this each time?
Yes, I did.
Oh, wow. Okay. That's going to take me a while. But, Sawyer, do you see what we're doing?
Is there a faster?
There is. I'm not going to show you.
That's so mean.
Wait, can't you just do the derivative?
So, that's the first 3. So, at 2. Because I'm fancy, people. That's how I just copied that. So, all right, guys. So I just did Y1 at 0.5, Y1 at 1. I could have added all 6 together. I copied this. How did I copy it? If you do second entry, it brings up the last thing you type. So right now, if I say plus, it takes my last answer. I don't know if this is going to work. Okay, that, so that's my first thing, plus 0.8647772, I don't know. So I got that answer, but I forgot to divide by 2, and I get that 5.926 or 5.927. Both of them would be correct. Okay? You guys okay? Sawyer making any sense at all? Still not. Okay. Well, Are you guys okay? Are you guys okay with this? Annalise?
How, like, what will the AP exam accept? Only the right answer if you're off by like 0.01? Like, will they accept that?
Okay. So guys, can you listen to this question about AP exam? I have graded this question twice now, and by twice I mean 800 or so problems of this. They want to see that you understand what they're asking for. So for RRAM, I am writing in highlighter, cool. For RRAM, they want to see this written out. Like, you could use the actual Y value here, but they want to see that you knew to choose that height, this height, that one, and that one. So you will get a point for showing some symbolic thing of I am doing the width times each of these heights. 1 point for that, 1 point for getting the numerical answer. And they will have a little bit of tolerance to that 3 decimal places, but not much. And then sometimes there's another point for getting the units correct. Okay, so they want to see this. So as lazy as you want to be, show them this because they'll get you. And your little dog too. And this was rectangle 1, width times height. This is rectangle 2, width times height. And sometimes it's on the non-calculator piece. We will do some of those problems. They're not as horrible as you think. Okay, really, it's okay. You're making a face, it's okay. All right. All right. This, I'll show you the first thing just because it amuses me. And we'll get an ad, I'm sorry. Oh, we do. Oh, we do. Look, the California cop car is trying to stop the Lamborghini and give them a speeding ticket. They're like, sure, right. Where is this vehicle? Okay, so there's that. Believe it or not, Calculus Rhapsody, it's real. Not today. But so this video is old and it's before GoPro. I don't know exactly how they're getting video of their speedometer as they are speeding through a tunnel. You'll see like it looks like flames are coming up from over here because it's like yeah, good times. So we're gonna mark the speed. Grady, can you be our scribe and put, or someone over there, I don't know, Matt, Alex, someone, like it requires standing. Oh, good catch, Matt. I think that means you've been volunteered. Okay, so at time 0, our speed is 0. All right. So, Juan, you get to be the first interpreter. At 5 seconds, tell us what you think the speed is. Okay, hold on. Oh, this is in the way.
Yeah, 10-ish. Like, I'll put like 11.
No, one.
So 11? Is that what you say? Sure. Okay.
I think it's the angle. I think that is it.
Okay. Well, Megan, you get to tell us at 10. Oh, good Lord.
Wait, you can like 68.
It's her choice. Hush.
No, I'll agree. 68.
She actually answers 68.
They 100% had their phone. It's like shaking so much.
Okay. David, at 15 seconds.
I think you're 105.
105. I heard 105. Okay. Becca.
Say it right there.
Becca at 20 seconds.
Oh no, it's
129. Okay, Alex at 25 seconds. 148. Okay. Adrian at 30 seconds. See the flashing lights? It's not on fire. 150? Okay. Oh, I'm at 31. Oh, well. We'll still count it. All right, Michael, 35 seconds. 156. Okay, Quinn, 40 seconds. 160. Danielle, 45 seconds. 173. Okay, Sophie, you are the last vote. At 50 seconds.
181.
181.
That's insane. How many laws did they just break?
How many laws did they just break? I don't think they care. All right. So, our numbers.
It's a guess.
0, 11, 68, 105, 129, 148, 150, 156, 160, 173, and 181. Okay. In 5 rectangles, what's our DS? 10. Okay, so I want you guys to do R RAM. I want you guys to do L RAM. You guys did M RAM, and you guys did M R L.
So 60. Oh wait.
So it's just yeah, no, because we're doing
Oh wait, yeah. Why am I doing this by hand?
But if you're doing the second layer, the second step.
What are you confused about?
A bit of an over.
No, wait, divide that by 36.
This has got to be like.
This is witchcraft math.
This has got to be like 4 hours.
No, I think 2 miles is definitely not reasonable. No, it's 1.9 miles. Well, I mean, you could go 1.
Yeah, I'm saying like, that's not like.
No, wait, that wouldn't work. You have to average speed.
Yeah,
Because he hit 120 as well.
Do you get 6,600? Do you get 600, 880?
I How many seconds an hour?
Anyone get numbers?
7.
That's this one, 5,000,
I did not.
930,
We have 5,700 for 5,000 seconds.
and you guys are L,
L-rim.
5,970.
5,000.
Oh yeah, and it's
R-rim, so it's like rest.
6,000.
It's R-rim, so it's.
Okay.
Let me see.
Board's being crazy. Okay, so, now, guys, we need to think about this. It is a Lamborghini, but it was only 50 seconds. What the heck are the units on these things? Did it go 5,300, like,
Miles squared per hour.
what the heck are these units? Like the space shuttle moves this kind of speed, like,
Oh, wait. Yeah.
okay, so what units are our time in this? Seconds. What was our velocity? Miles. Okay, that's a problem. So we just did miles per hour times seconds. What do I need to multiply by to fix this? I need to get rid of hours and get rid of seconds. Jan, what do I need to do?
You have to divide by 3,600.
Because in 1 hour, there's 3,600 seconds. So then hours cancels with hours, seconds cancels with seconds, and then you end up with miles. So 1.4 is
L-rim.
1.64.
Might have been 1.4 miles.
1.91.
1.91.
Okay, so looking at, okay, so the mileage here, it's only had, yeah, 224.4, okay? And let's see, it starts at, so, goodness, the board is crazed today. Okay, it's about to die and go to spinning to death. But, it, by this odometer, I wrote a 1 again. It went about 1.5 miles. So the area of the curve that you guys calculated, MRAM was closest. It's not always. But it's to show you, like, we added up rectangles of the velocity, did some over approximating, some under approximating, depending on which triangle you were. Oh, where does it have the greatest acceleration? Over what 5-second time frame?
Oh,
5 to 10, like big time.
oh yeah.
Yeah, that's my car, Yeah. Trying to downtown,